Okay, as we are discussing the rules of resonance, so we are continuing with the rules. So this is another rule which shows that octet of the second row's elements should be complete. So those elements, the second row elements of the periodic table, just like nitrogen, oxygen, and carbon, when their octet is complete, those structures will be regarded as good. So this is one resonance form and this is another resonance form. These are again the same resonance form, a resonance form of the same molecule. Here, as you see, this is a cation, okay, and to the carbocation there is adjacent nitrogen. Nitrogen has a lone pair present on it. Now the lone pair can shift and make a bond, so it can be converted to a bond pair. So as you see, both the lone pairs are shifted and produced a bond or form a bond. Now what happens, as you see that the nitrogen, which was initially neutral, now it transferred its lone pair and form a bond with it. Okay, now those become a bond pair. These are bond pairs, okay, or part of a bond now, a pi bond in fact. So the neutral nitrogen then acquires a positive charge. Here the oxygen does the same thing. Its lone pair forms a bond and a pi bond is produced, and the oxygen acquires a positive charge. Here as you see that this carbon atom and this carbon as well, both these carbons are electron deficient or their octet is not completed. As you see that this carbon forms three bonds, one with the nitrogen and two with the hydrogen. So it has 6 electrons surrounding it. Okay, so its octet is incomplete, and here this carbon has also 6 electrons present surrounding it, so its octet is also incomplete. Here as you see, now this carbon forms 4 covalent bonds and its octet is complete. In this structure the nitrogen acquires a positive charge, but as you look and count the electrons around it, it also again its octet is complete. The octet of the oxygen is again complete. So as according to this rule, those structures in which the octet of the elements of the second period is complete will be good structures. Okay, so according to the above definition, those are good structures. Again as you see, this structure is better than this one and this is better than this one. Again you see that here more covalent bonds are present and one charge. Here less covalent bonds are present and one charge. So this thing again obey the first rule, that the more the covalent bonds, the better is the structure. As I mentioned earlier, that we are right now not interested in the actual structure. When we understand those things, then we will be able to understand the actual structure. Okay, these are the tools that will help us to understand the actual structure of the molecule. Okay, or those molecules which cannot be represented by a single Lewis structure, because that is our target and we are moving slowly towards our target. So according to the above definition, these structures on the right, they are better than their left counterparts. So this is another rule which states that the positive and the negative charges should be stabilized. Okay, so in many textbooks you might have seen that this rule is stated as that the negative charge should be present on electronegative atom, and the negative charge should be present on more electronegative atom, and the positive charge should be present on the less electronegative atom. But the generalized statement is both the positive and the negative charges, they need to be stabilized. From what from stabilization, what I mean, it will be clear to you after doing some examples. Okay, so this is a ketone molecule. In organic chemistry, when we draw a line, when a line is drawn, this means that it is a CH3 and this is a CH3, because they devise this rule. Okay, so as an organic chemist, when you draw this line, all the other organic chemists will understand that it is a CH3. So this is ketone. Okay, now two resonance forms can be produced for this ketone. Okay, this is one and this is other. This form is produced as a result of this thing, when both the electron shifts to the ketone. Pardon me, that the ketone oxygen has 2 lone pair present on it. Okay, so when these bonding electron shifts to it, now the lone pair becomes 3. Okay, I think you will be seeing this. This is the extra lone pair, which creates a negative charge on the carbon. What if those two pi bonded electrons, they shift onto the carbon and sit on the carbon? Now the oxygen is positive and this is negative. So this is the best structure. Why? Because it has more covalent bonds present. Okay, 1 2 3 4 and 1 2. It is the best of the best. It's okay. And this is, you will understand that this is not okay. But for when you count the bonds, covalent bonds, both these structures have equal number of covalent bonds and have equal number of charges. But there is a difference. The difference is that the positive charge need to be on less electronegative atom, or the negative charge should be on the more electronegative atom, or we need to draw structures in which both the positive charge or the negative charge both need to be stabilized. Okay, as you saw, if someone is confused, they should watch the previous videos in which we discussed the effect of electronegativity or inductive effect on the resonance. Okay, that what is the role of electronegativity and the role of inductive effect in deciding the resonance structures. So that was discussed in the previous lectures. Okay, now this is the excellent. This is very, very good. Those two now have the same number of covalent bonds and have charges. This has 0 charges, so this is best. What about the others? This structure and this structure are now in a competition, but as you see that here the negative charge is placed on oxygen and a positive charge is placed on a carbon. Here the negative charge is placed on a carbon and the positive charge is on the oxygen. So what? This rule says that the negative charge should not be present on the carbon, on the less electronegative atom. Or the positive charge should not be placed on the more electronegative atom. So what does this statement means then? As you see, what is electronegativity, or what is more electronegative atom? The electronegative atom is an atom which needs electron, okay, which likes electron. This is the simplest, very simple statement, which is very much sufficient for a basic classes. Okay, so oxygen is, as you saw, as I previously in the previous lecture we discussed that suppose you have a bond between carbon and oxygen. Okay, this oxygen, what does it do? This oxygen want the lone pairs the bond pairs need to be near to it, because it likes electron, it attracts electron just because of its extreme nuclear pull. These are the bonding electron, and still it attracts the bonding electrons, or the bonding electrons are farther from carbon and are very near to the oxygen. In this structure it is okay. It seems a little bit, when we compare both of them, this is good, because the oxygen likes electrons and you placed electrons on the oxygen. Okay, It is good but not good than this one, and we will study that how those structures will lead us toward the true structures. Okay, but you might be saying, okay, this is a positive oxygen, and I say that this is not good, it is worse. But in the previous section, when we were comparing those structures, those resonance form like this is suppose B, and this is C, and this is D. I told you that D is good, but again, as you see, it seems that it is violating this statement. It is a positive charge on an electronegative atom, and I am saying that this is good, and here I am saying that this is bad. Either what is happening then? There is a problem. Number one thing is that octet should need to be full for the atom of elements of the second period. Okay, so as you see, this oxygen, it has an octet. Okay, or it has 8 electrons around it. Two lone pairs and 1 2 3 3 pairs of bond pairs. So 2 4 6 and 2 8, but it acquires a positive charge. Okay, so this is electronegative atom, it acquires a positive charge, and which this statement prohibit. It said that don't write a positive charge on an atom which is more electronegative, and I say that this is good. Okay, now here it is a positive oxygen and this is a positive oxygen, but we need to give preference to the octet rules. Okay, the octet rule need to be preferred. Now this has octet complete, this oxygen, this has an complete octet. 8 electrons are present around this oxygen. This is good, but as you see, this oxygen, it is a positive, but it's an electronegative species which wants electron. Okay, but here it has 6 electrons in it. Okay, so this is very bad, because an electronegative, these are two, both have the positive charges, but this poor fellow has a positive charge and has 6 electrons. This has a positive charge but has 8 electrons. Keep it in your mind when drawing the resonance structures, because here the octet is complete and here the octet is incomplete. Okay, now let's move to this structure. The carbon, its octet is incomplete. Okay, as we saw that we need to prefer those structures which has octet, their octet complete. So this is best of the best, this is second best, and this is worst, because in the presence of carbon, oxygen has a positive charge and incomplete octet. Again, here oxygen has a positive, carbon is neutral, but here what is happening? The octet of the atoms is octet of both the atoms are complete, so the octet should be given the preference over the positive or the negative charges. So first we need to look to the structures, that whether there is a chance that an octet of all atoms should be complete. If that is complete, then okay, go for that structure. If there is no issue of an octet, just like in those structure, in both the cases you have option. Either you need to have incomplete octet for carbon or oxygen, incomplete octet for oxygen or carbon. So there you have a choice. Now you have to write a structure in which the octet of a more electronegative atom should be complete. So as you complete the octet of the more electronegative atom, what happens? It acquires a negative charge. So the rule states that write a negative charge on the more electronegative atom. Okay.